Okay, so I want you to try a problem very similar to what we just did in example 2. I want you to try it on your own. And I'll just give a little bit of an explanation before you go ahead and do that. We've got two swimming pools, a larger one and a smaller one. The larger one has 54,675 liters of water, and it's being emptied at a rate of 25 liters every minute. The smaller pool has 35,000 liters approximately of water, and it drains at a rate of 10 liters per minute. So just like the last problem, we've got a big giant thing that is filled with something to start with and then is slowly being drained, right? It's very similar to the grain bins that started full with grain and then were drained so many cubic meters every minute. And so what I want you to do is I want you to model the change in the volume as a function of time for the large pool and the smaller pool. See if you can create a system of equations that models the volume for the large pool and for the smaller pool. And then after you're done that, graph them on your calculator and see if you can find the point of intersection and interpret what that point of intersection means in context of the problem. Okay, so pause the video and give that a try. Okay, so let's take a look at this. The larger pool, its volume starts at, let's see, 54,675 liters, and it drains at a rate of 25 liters per minute. So it goes down, so I subtract 25 liters every minute. We can just put M for minutes. For the smaller pool, we start at 35,000. So our initial volume is 35,400. And we go down by, 10 liters per minute. And there we go. There's our system of linear equations. Let's graph that on a calculator and try to interpret what that solution means. So the larger pool started at 45,675 and it goes down 25 liters every minute. The smaller pool started at 35,400 and it went down by 10 liters every minute. Let's think about our window settings. X is time. How long would it take to empty that pool? Well, if you're not sure, maybe you had some troubles with your window settings here when you were trying it on your own. I'm just going to leave it there for a moment, just to show you a trick that I sometimes use when I'm not really sure about how far X should go out. Y, however, we should have a pretty good idea, right? The smallest volume will be 0, and the highest volume will be the volume of the larger tank, which is about 54,000 liters. So I'm going to put it at about 55,000. And let's just graph what we have so far. Okay, so you can see that we have both of our lines in the window, but we have no idea where the point of intersection is. It's not even viewable at this moment. But you should know that these lines have negative slopes, so they'll be going down as we go from left to right. So these lines are sloping down, meaning that their intersection points is probably way off to the right, right? So that gives us a hint as to how sizable the X max should be. So 80 is obviously puny in comparison to what we need it to be. Let's try 2,000. Let's try 2,000. Make it pretty large and see what we see. There we go. That's much better, right? So as long as you have an idea of what your lines are doing, and if you can see a piece of those lines, you can adjust your window settings appropriately based on their behavior. So let's find that intersection point. Second trace 5, enter, enter, enter. There's our intersection. So what is this saying? Well, this is saying that in 1,285 minutes, both pools have a volume of 22,550, right? And 1,285 minutes is about 21 hours. So that's a pretty slow drainage rate. That would take kind of forever, right?